right, since we are at the 5 o'clock mark, I guess we will get started. Thank you, everyone, for making time to join this webinar on first year engineering, the common first year that is at Lassonde. So you can see we have Professor and Director of Common Engineering, Jeff Harris, with us today. So he's really going to take the lead here, but if you have any questions for us at any point, feel free to leave them in the Q&A. And Catherine and we will be monitoring, and we'll also make time near the end of today's session to answer any questions that you have, all right? So without further ado, Professor Harris, take it away.
All right, thanks so much, Anna. I'll just share the slides I have here. Okay, so you should be able to see me and some slides here. So today we wanted to give you sort of a sneak peek into what your first year in engineering will look like at the Lassonde School of Engineering. So myself, I'm a professor in mechanical engineering, but I oversee all the first year engineering at York University. So I'll be speaking about sort of what your first year could look like next year. Okay, so we have our first year engineering program at two different campuses. The Kiel campus is our large main campus of York University. We'll have a cohort of about 700 first year engineering students next year. You'll be divided into the lecture sections of about 180 or so students, but then those lecture sections get broken down into smaller groups at about 30 students. So you'll have a bigger group with your professor, but then a smaller group with a teaching assistant where you're actively working on problems, doing labs. That's about the same size as a high school class. You can start your degree in September or January at the Kiel campus. At the Markham campus is our newest campus that opened a couple years ago. We'll have a class of 135 first-year engineering students there. It's a bit of a smaller campus feel. The number of students at that campus is about the same as a larger high school, so it has that similar kind of vibe to it. And especially for students who live nearby, that's often an easier transition into university. And then students who start their first year at the Markham campus will transition to our main campus in second year when you specialize into a specific engineering program. In terms of how we introduce first year engineering, I put a whole bunch of pictures up here, but one of the tools we use is Lego as a facilitation tool to get us talking with one another. And we do things like building a tower. And putting a marshmallow on top to introduce teamwork and think about how we work with one another in teams. Sometimes we do interactive things in classes like put sticky notes as we brainstorm about different scenarios and different types of technology and ask you to think about what you would do in certain situations. We also like to bring in world case studies. So I have a bunch of pictures here on the right to kind of talk about them. For introducing ethics, we've looked at a case with the Boeing 737 MAX and software that they had on there that was faulty and led to some terrible accidents. But we break that case apart into the decisions that were made and how the engineering was designed to explore different dimensions of ethics and how to conduct yourself professionally. A few years ago, we did an assignment where we were using open data from the TTC to analyze the causes of different bus delays in the system and to propose potential solutions to address those. And You see another example of the City Core Tower in Manhattan in New York, which is another ethics case study that we look at. When we teach computer programming to engineering students, we do it with the software and the hardware together, where we teach through mechatronics hardware. So you're not just coding and seeing things happen in the screen, but you're taking in data from sensors and you're making things happen, like controlling a water pump or a motor. And having these kits allows students to come to campus and do their lab, but also bring the lab home with them and continue working and practicing and debugging at home. And that provides the opportunity for open-ended projects where students can really do creative things um, with computer programming. We have what's called experiential learning embedded in our curriculum, and as part of an assignment, you might do a design competition or a case competition or a hackathon where you're engaged with one another in groups and working on solving some kind of problem, whether it's virtual based or physical based. At the Kiel campus, we offer two different learning models that you can choose from. We have what's the traditional model, how engineering is traditionally taught at many universities, where students take 5 to 6 courses at a time in 12-week terms. Usually, it's about 20 to 30 hours of class on campus each week and 5 days a week on campus. We also offer a block model where students take 2 courses at a time, but they're taught in shorter sequential modules. Um, and with one course that goes over the term to knit things together. In that model, students have about 15 hours a week on campus, which is a 3-day week on campus. That's complemented with about 6 hours of week online. I want to talk a little bit about the curriculum for the block model, and then I'll talk about what the curriculum looks like in the traditional model. In this block model, your first week is really an on-ramp, learning what engineering is, what engineers do, preparing you with some of those foundational skills to understand how engineering might be different than math or science or things you've learned before. From there, you will go into a 5-week block on fundamentals, where you build on your calculus, your physics, your chemistry in a really integrated way. After that, you shift into a series of mini projects where for 5 weeks you do a new project each week. You start off with sort of this challenge, and then you learn the fundamentals, skills you need in order to be able to solve that challenge and finish it by the end of the week. And then that fall term or that term one is ended with a design sprint where you're tackling some real world challenge in a team over the course of 2 weeks. This is supplemented with, over the term, a block on learning foundations where we emphasize habits and study skills to thrive in first year engineering. And we add a layer of sustainability, looking at the Earth as a system. So introducing systems thinking along with sustainability together. So, for example, in that mini projects course, you might have a project one week, or you'll have a project one week where you're asked to design a truss-based solar panel mount. And you're given this challenge at the beginning of the week and say you need to deliver on this by the end of the week. To do this, you need to know some math, you need to know some coding, you need to know some prototyping. So we say, okay, here's your challenge. Let's learn a bit about matrices, and we're going to teach you what you need about matrices to solve this problem. We're going to teach you a bit about coding and computer programming to solve this problem. We're going to give you an opportunity to do a hands-on work and build and test things in order to solve this problem. So it's really about learning the math and the coding in a practical and supported way, so that you solve real-world problems. And this will prepare you for the rest of your engineering program. Um, so it has what we call just-in-time instruction, where those mathematical and programming concepts are introduced exactly when you need to learn them. Um, and we hope that reduces a lot of the overhead in terms of developing your understanding. Another one of the courses in the block model is that design sprint at the end of the fall term. Sometimes it's called a hackathon. Over 2 weeks, you'll work in small teams um, to develop a solution that tackles a grand challenge. Um, you'll be guided through a process to identify a real problem, develop a solution, test, validate your ideas, and also practice communicating your work clearly and persuasively to others. In the second term of that block model, you have your engineering design course that goes for 12 weeks, and then you spend about a month on calculus, on structures, electricity, and computer programming. If you're doing the traditional curriculum, it looks a little bit different. You'll have 5 or 6 courses all at once, and each semester is 12 weeks. Engineering 1 focuses on problem-solving ethics and communication skills. Um, Computational thinking is your introduction to computer programming. You'll have a calculus block, calculus course, linear algebra, and a physics course. Your second semester builds on the first with your engineering design course. Um, that course is shared between the traditional and the block model. You'll have more computer programming, more calculus, more physics, as well as chemistry and either discrete math or earth environment or a mechatronics course, depending on where you think you're going in second year. So that engineering design course in the second semester is a real highlight for our students, where in past the themes have been around sustainable development goals, and we have a big showcase on campus where people can come in and see your poster display. We have judges from different industries and companies come in and engage with our first year students to really share what they've learned through this journey over that 12-week semester. So there's different pathways for that first year, whether you're looking for a big campus experience, a small campus experience, a block model, or a traditional model. But all the pathways give you a strong foundation for whichever engineering discipline you're choosing to go into second year. Every engineering school or probably every university that you talk to will tell you about all the student supports that they offer. Um, and every university has an interest in seeing their students do well. So there's a bunch of things that we have at York in the Lassonde that you'll see commonly at most campuses that you're considering. The things that separate Lassonde apart, I think, from other institutions are some of the supports that we embed in our courses. So in your first semester, you'll be assigned to what we call a pod, a small group of about 4 or 5 students, and you'll engage with one another each week during your tutorial. So you'll develop connections with peers in your courses. But as a pod, you'll also meet with a peer mentor, an upper year student who's been through what you're going through now, who can give you advice and tell you about things you might wonder about, like how to apply for co-op. Um, And the other thing that we offer are different avenues in the summer to help you prepare for your first year. So that's a quick run through of sort of your different options for first year and what you might expect if you come to engineering at Lassonde. I see there's been some questions in the Q&A, and I think Anna's been monitoring those, and Catherine's here to help answer questions too. Maybe Anna, you can facilitate us through
Yes.
what you've seen.
Of course. So we have a great question here, asking about the block model. So the student is asking if the block model runs for both semesters of the first year or if it's only available for first semester. So they may have seen some information floating out there about the block model.
Yeah, so this current year for our first year students now, it's just first semester, but next year it will be first and second semester.
Right. So if you are a fall entry student, if you've applied for fall 2026, congrats, you're going to be the first cohort to participate in a full year of block model if you choose to do so. And of course, if you are studying with us here at Kiel campus for first year, that is
And,
an option for you.
and the students who have done it in the first semester have really been asking to do it in their second semester. What a lot of students like about it is that focus on one core subject at a time. You learn that subject, you write your exam, you move to the next module. Um, some students like that compared to having five or six things to balance all at once.
Mhm, mhm. I'm sure Catherine can relate, given that she is not only our civil engineering student ambassador, but she was a participant in the block model. So I don't know, Catherine, if you have any additional comments or your personal review of the block model.
I personally love the block model. It really helped to just focus on one or two courses at a time as opposed to five or six throughout the entire first term. I am a little bit jealous though that people who will be applying will get to do the whole year because I only had it during my first semester.
Mhm. Yeah, and we're expanding it now as well, right? So more students will get the opportunity to opt into the block model if they're interested. And if you are curious how to opt in for the block model, this is another common question we receive. If you've already applied for engineering here at Lassonde, you would have received in your email your engineering co-application. So it is within your co-application that there is a field where you can indicate if you're interested in joining us for the block model or you want to stick with the traditional model there. Okay, so that's a way for you to indicate your interest early on. And then once you get to the enrollment stage, academic advising will reach out to you and let you know how you can go about enrolling in the block model. But it is a really exciting opportunity for our engineering students. Um, had another question here, and I'm sure um, Professor Harris or Catherine, you could address in terms of the age range of students that you might see in some of your engineering courses. I guess the students just wondering what the demographic is like. What has your experience been?
I can maybe Catherine, why don't you go ahead?
I find that there's a wide range of the age of students in my classes. It could be people who have just come out of high school, and I've met a lot of people who have already had a degree, and so they're like a little bit older than I am. But really, it's a mix of different levels, experiences, backgrounds, and you really get to meet a diverse group of people.
Yeah, I see the same thing in courses when I teach. We have a lot of students coming straight out of high school, but a lot of students coming here later in their academic career, whether this is a degree change or they've done a diploma in the college system. Actually, some of our best students um, have that college experience, and they're really fun to teach. And um, I've had one or two students do an engineering degree in their retirement where they've they've worked their career and they're looking to sort of keep their mind active and have chosen to do an engineering degree. So we get students from all walks of life in our classes.
Mm. Definitely. And it's great to see. It's great to see a diversity in our student population. This question here is related to admissions, so I might just step in and say, I know this is a lot, this is on a lot of students' minds. When will they receive an offer of admission? Because they might be right now in the waiting stage, which is probably the worst phase you can be in because you're a little antsy, right? That being said, if you are still waiting for a decision on your engineering application, you're hearing all these great things about first year and you just want that offer letter in hand, don't worry. Admissions is an ongoing process. Okay. There are rounds of admissions, and every time we receive updated grades, especially if you are a high school applicant, once we receive updated grades in OUAC, admissions will go back and review your application to determine eligibility, okay? And in fact, majority of our offers are made typically around March. So it's actually very normal at this stage to be waiting. Once we have your grade 12 semester one finals, we'll be able to get a better idea of where you are, where you stand, and then hopefully be able to make a decision. And if not, we'll hold off until we get the next round of marks from you. All right. So just hang tight. And if you have any questions at the end, we'll share some other ways to stay in touch with us so that you can reach out to us later down the road as well. All right. Great question, though. Now, for students looking ahead, they're hearing great things about first year. They're starting to think about second year already. They're wondering what kind of academic, specifically GPA requirements are, are needed in order to be able to continue in their engineering program. I don't know.
So do you want to talk about the program guarantee?
Sure, yes, I would love to. And then perhaps we can then segue into GPA because I think that's really the
Yeah,
only thing you need if you have your engineering program guarantee.
yeah.
So I'll backtrack and say I know a lot of students, if you've been looking across other universities, you see that some universities offer direct entry into engineering specializations. But as Professor Harris went over today, Lassonde is unique in that it does offer a common first year, right? So you have some time to explore before you have to decide, make that sometimes difficult decision of declaring a major. That being said, we also know a lot of students come in to first year already having an idea about what they want to pursue, right? Which specialization. So if you already think you know what you want, that's what that engineering co-application that we had emailed you in early February is for. Okay, so make sure you go through that co-application carefully because there is a field where you can indicate your top engineering program choice and your backup choice. After you submit your co-app to us, we will then make sure that we have enough spots in all of our programs, and then we'll reach back out to you to let you know which programs we can guarantee you a spot in for second year. So let's say you are super excited for mechatronics, right? If you indicate your first choice is mechatronics, maybe mechanical is your second choice or your backup choice. In April, we'll reach out to you and let you know, hey, we can offer you a spot in mechatronics or mechanical engineering. Which one do you want to lock in? You just have to confirm with us that perhaps mechatronics is still your top choice. And once you've locked that in and you secure your admission to engineering, you can go through first year engineering knowing that you have a spot in mechatronics reserved just for you, as long as you can successfully progress in the program. So correct me if I'm wrong, is the GPA requirement a C or C plus, I believe?
It's a C.
Okay.
So for your degree progression, as you progress through your degree at York, um, going from first year to second year, we look for students to have a C average. I think when you graduate, it has to be C plus, but usually students' grades go up as they get to choose more electives and specialize more. But we look for a C average. And then students who are below that, depending on where they fall, may have the opportunity to repeat courses. And when students repeat a course, their new grade replaces the old one. So there's an opportunity for, things in life sometimes happen, and unfortunately, and um, there's safety nets in place to help students who need extra support or some extra time.
Yeah, it's a forgiving process, I think. Like you said, a lot of students, especially if you are entering university or engineering for the first time, right? And maybe it's a big leap. And there are some things in life, like Professor Harris mentioned, that kind of, just pop up. Just know that we you not only have supports in place to help, but also there are opportunities to make up, right, for anything that perhaps didn't quite go your way the first time, right? Let's take a look here at the next question. Uh, Regarding engineering, we do often get the question of, is there a mandatory supplementary application? So no, there's no mandatory supplementary application. The engineering co-application that we've been speaking about, though, is completely optional. Okay, so it will not affect admission decisions. Even if you don't fill in the co-application as emailed to you, it will not affect your admission to engineering. However, it may benefit you personally to either secure a spot in your preferred engineering program in advance or to opt in for or to opt in for the block model if that's something that interests to you. So no mandatory sub app, but there is an optional co-app that has been emailed to you already. Right. Um, the student is asking about how to prepare for first year through the summer. So if there are any prep courses or maybe anything that they can do so that they can feel ready for first year.
And so sometimes we offer through Lassonde different opportunities to give students a boost who are looking for that. Um,
I
and
do.
is the Lassonde Academy something that's being offered this year?
Yes, I was just going to say the one thing that comes to my mind is that we do have optional Lassonde Academy online modules that are available to all incoming Lassonde students. So typically it's later in the summer, around August. We will email you information about how to kind of participate in this optional module if you wish. But you'll automatically be enrolled in this course in e-class once you have access to that. So you might have to wait a little bit until you gain all of your enrollment accesses. But essentially, it's materials, coursework to help you refresh any maths or science skills that might be helpful in first year. I'm curious, Catherine, now that you are an upper year student, if there was anything that you did, whether it's before you joined first year or any advice you have for anyone who is joining first year to prepare.
To prepare in terms of courses, it is like always great to go back to the basics and like any knowledge that you can get or review before going into Lassonde and engineering courses. Of course, they'll teach you in your first year everything that you need to know, but some basic knowledge is always really helpful.
Agree. I have heard that as well from students. They mentioned that, especially first term, some of the materials are like, "Oh yeah, I remember this from high school," or "Oh, I wish I paid more attention in high school." So maybe that's a gentle reminder to everyone here to number one, if you are currently taking courses, focus on the classes that you're currently in. Really try your best to finish the year strong because that ultimately is the best prep you can do, prior to your first year courses. So that's my little
Yeah,
tidbit.
I as a professor, I have to say, developing good study habits when you're in high school will carry over and help you in university. And if you're the type of student where high school comes really easy to you, it can be tempting to coast through with sort of mediocre study habits. Um, I kind of sound like I'm describing myself. But when you get to university and the level goes up a notch, having those good study habits will really help you. And then for some people like me, it takes getting your first test back to realize that you need to focus on that more. Um, but those good habits do help a lot.
Mhm. Completely, wholeheartedly agree. Um, Moving on to another question, a very fun, interesting one. The students wondering about um, other types of projects they can expect or anticipate going into. Maybe they hadn't specified first year, so maybe just in general engineering at Lassonde. So whether Professor Harris, this is a project that you really enjoy, or Catherine, something that stands out in your Lassonde journey so far. What could you share with students who are curious?
Maybe Catherine, you can jump in first with that one.
I can try. Yeah, at least in first year, there are so many different projects that you get to do. Because you have labs, we get to do a design project in some of the courses and learn about the whole engineering design process. Um, it is like some of the coding. I think you showed a picture of the Arduino. Um, you get to actually code and use it. And I think one of the projects is we got to do a plant watering sensor. A lot of the physics labs in second year are also very hands-on. We learned about circuits. Um, yeah, overall, and of course, in upper years, you get to do so much more. For example, in some of my courses, because I'm in civil engineering, we've tested concrete, we've made concrete, steel, we get to see how water flows. Professor Harris, do you have any other projects?
Yeah, there's some hands-on projects and there's some more conceptual type projects. Um, I think you mentioned the that sort of plant watering system, using sensors and the water pump and creating that really in an automated way. Um, some of the other things that we're looking at doing next year. One is a map building exercise where we take a big set of data collected from a LiDAR system, and then it's really about applying linear transformations. Um, Sorry to use some technical words, um, but it's really about um, computational robotics, and in terms of building a map from a big set of data. Um, in terms of student design projects, Catherine, do you remember what you did for your first year design project?
Ooh, the one in first semester or second?
Second.
Second, yeah, I did. I focused on the transportation system, and so we tried to redesign some different ways to use public transportation or expand it. And then we made a poster. I I think it was a group project, right? And then,
Yeah.
yeah, that one was really fun.
Yeah, I'm in this group chat with engineering professors from all across Canada, and we share notes with each other. So I kind of get an understanding of some of the differences between York and other places. And a lot of universities give you a really clearly defined project to solve in your first year. Where at York, we say, okay, here's a challenge, but find what the problem is in here. And it's more of an uh, entrepreneurial thinking approach that we give to that first year, where we ask you to find something meaningful to do that will actually benefit people. And we give you tools to try and explore that space. But we don't need more engineers who can just add extra buttons and extra features to uh, a good solution that already exists. We want you to be able to identify needs that are out there and develop solutions for them.
Great, fantastic. It's also fun to hear that profs are also sharing notes and have a group chat. They're also still just students learning and growing.
Yeah.
Love it. Um, there are some more like admission related questions here that I can definitely address later on. But I guess building on the previous conversation about preparing for first year courses, this student is wondering, are first year courses then simply just a recap of high school material, or would you say there's more complexity to it? Or I guess how can they I guess what can they anticipate, I guess, in first year courses in comparison to high school materials?
If you do the block model, that curriculum is not a recap of high school. We start with a problem and then teach you skills that do build on what you learned in high school, but it's all focused on application, connected to engineering. If you're doing the traditional model, you'll see a lot of your course titles may be similar to what you've done in high school. Um, the learning is designed to be an extension of what you've learned in high school and some of the maths and the sciences. We know our students come from very diverse background, whether you're from abroad, whether you're from within Canada, whether you're coming to university later in life. So depending on your experience, the first couple weeks might seem familiar to you, but it picks up quickly and you do learn new things, quite a lot of new things in your first year.
Great. Do students work on their own projects? So I know we spoke a little bit about, projects they do in courses. Do students kind of pursue their own personal projects? What are some personal projects that maybe you know about or you've heard that students have kind of been pursuing on their own? There's another interesting question that was in the chat here. I don't know if Catherine, you or your peers have any as well. I do hear that students kind of pursue their own projects. I haven't seen one myself, but I do know that our students are very multi-talented. And in fact, I always hear of our students, even if it's not personal projects, like involved in so many clubs and competitions despite their very busy schedules. I know that that's something else when students hear about engineering. They expect like a rigorous schedule, which can be the case, especially if choose the traditional model. You're juggling courses, deadlines, all of that, but they still manage to find time for clubs and competitions and their own personal interests. So clearly, our students are passionate, I think, about what they do, and they're surrounded by like-minded peers who maybe motivate and inspire them as well. I guess I'll take on a part two to this question in case either of you needed more time to brainstorm. Another question is, I guess, what about clubs? What kind of clubs exist on campus? What can students look forward to joining, maybe from day one in first year?
Catherine, I know you've been involved with a lot of clubs, so why don't you share your experiences first?
Yeah, of course. So there are so many different clubs on campus, first of all. So basically any club that you can think of outside of Lassonde probably exists. There are cultural clubs, there are clubs with hobbies, there are sports clubs. If you have an interest and you want to meet new people, there is definitely a community for you. In terms of clubs at Lassonde, there are quite a few. So, for example, we have our Lassonde Engineering Society, which focuses on a bunch of social and academic events for the community. We have our Women in Science and Engineering Club. We have our robotics club. And we also have a bunch of design teams, if tying back to the project aspect, where they get to build a structure and compete against other universities. So, for example, we have a concrete canoe, a concrete toboggan, steel bridge, and they actually build all of these components using the resources in our labs. And we, I think one of them just had one of their competitions. I'm not sure how they did, but it's really exciting and there's always so much happening around campus.
Yeah, I think it was the concrete toboggan that just had their competition, and there's a bunch of different categories, but in terms of race performance, I think they got third in Canada this year. And it's a really cool team because you get students from different engineering disciplines working together. The skis for this toboggan are made out of concrete, and there's a lot of civil engineering work that goes into that design. But then the braking and steering mechanisms. You've got mechanical engineering students working on there. You have students from outside of engineering helping with the business plan and sponsorship and all kinds of things with that one. That's a really cool club. Um, the Motorsports Club is building uh, a small formula car, and they're in the middle of constructing the first one that Lassonde's going to race. And I think they go down to Michigan in the spring. And I saw their structure just got in. They just finished welding their structure together. So it's cool to see that come together. Um, and then we have some students who have their own passion projects that they pursue. Um, I often hire undergraduate students to do research with me, and I had one student, she was into mechanical engineering, but also into fashion, and she um, looked at repurposing like used clothing, but sort of upscaling it in a way, and she um, while she was a student, she had her own online store where she was found like new homes for these different fashion things. So that was really cool. Um, but it's as we get to know our students, it's amazing all the different things that they do.
Think I was chatting with some students. Catherine, maybe you were there as well, about how a Lassonde student was it they had created a website or something to help them with scheduling class schedules. Something. So this was definitely just a passion project that they took upon themselves. They just created this website because they were having trouble figuring out how to, I guess, maybe make their courses fit. So they just created something to help them and then shared it with their peers. And we were like, we need to get that student to do this for every Lassonde student.
Yeah,
They,
yeah. I think it was a website that mapped out where you kind of want to go, and then it had like almost a flow chart of all the prerequisites you will need in all the courses, and it was so cool.
yeah, so they took like our existing materials from like academic advising, from the academic calendar, and they kind of compiled it and created. So I was thinking of how this clearly stemmed from a student's like not only need, but they expanded beyond that, right? They did it for a lot of courses that they probably weren't taking anyway. They just did it out of interest and passion. So it's really interesting to see, I guess, not only the interests that our students have, but the community we have here because they created something and then shared it with their peers, right? Because they thought that it would be helpful. So I think that that's something that just popped up in my mind right now. Yeah, and I remember you folks were the ones who told me. About it. Um, Now kind of this is actually a fun little question for Professor Harris. Um, do you have any pet peeves or anything that maybe first year students do in your lectures that you're like, oh, don't do that, or try doing this instead? The student's a little intimidated, they're a little nervous about entering large lectures in first year.
Large lectures, Well, I encourage students to participate. I encourage students to ask questions. And often, um, the one student asks a question, and then 20 other people in the room think, "Oh, I'm glad that person asked that question because I had the same question too." So I encourage that students ask questions a lot. In terms of peeves, um, maybe students talking in class when they're not supposed to be talking, or students not talking when they're supposed to be talking, or if you come to class and you're just watching a soccer game on your laptop or doing gaming on your laptop, no one's forcing you to come to class in university. It's your education. You're an adult. You make your choices. So if you want to do those other things instead of coming to class, that's your choice, but don't come to class and distract other people with what's on your screen.
Excellent advice. I'll kind of turn it to you, Catherine. Do you have any advice for first year students maybe joining these large lectures for the first time?
I mean, I agree with Professor Harris. When, you're trying to pay attention in class and then I just like hear the people behind me like talking. But in terms of advice, just be there, and if you're there, then try to get something out of the lecture and learn. Even if you've had like a really tiring day, um, if you want to make the effort to show up, you could learn a lot. And if you don't want to go to class to do that, then don't, disrupt the others. But yeah.
Solid advice. Speaking from experience too. So that's fantastic. Um, Let's take a look here. Ooh, a question about co-op. So this student is already thinking about co-op. Of course, I know that it's something a lot on a lot of applicants' minds. I'll start off by at least saying this bit. We often get questions about co-op, even for students who are at the application stage. If they're looking through OUAC, they're like, I don't see where I, have to apply for co-op. And that's because here at Lassonde, even though co-op is offered, it is optional, so you do not have to worry about applying to co-op at the application stage, getting into your program. But later down the road, it will become available to you. So this student in particular is just wondering about are they on their own looking for a co-op placement, or will the school help them if they're in engineering, kind of what their experience might look like if they're looking to join the co-op program. Catherine, I don't know if you want to share anything or if
Yeah,
you
I
want
can
to.
I can try to help with this one. So the school does have their own core co-op portal. And there the school York University has connections with a bunch of different companies. And so you can find job postings under there, and you can sort it by ones for your major. There's different topics, and it'll tell you what company it is, where it's located, all the information you need. I know so many people have gotten their co-ops from the York Co-op portal. I just did for this coming summer. Thank you, thank you.
This is news to
Um,
me. Congratulations.
yeah. Yeah, and but you also have the option to get a co-op externally. So you can apply to anywhere, and if you get that co-op, you just have to register it with the university for it to be a part of the co-op program.
Yeah, and the York Career Center and Co-op office has a team that reaches out to companies and develops partnerships. What you often find on co-op job boards, um, when their jobs posted by large engineering companies, they'll typically post their jobs at multiple universities. So if it's a GTA based company, they'll often post at all the engineering schools. And it's not who they hire they're really looking for students who find ways to differentiate themselves, who do things like engage in this club and show leadership or take on things on their own. And it's more about how you present yourself and how you stand out than which university you went to and that kind of thing. Um, and my wife's a senior engineering at a consulting company, and she interviews students from all different universities, and she'll say that like they've had um, successful hires from a whole wide range of universities. Um, and it's really speaks to the strength of the university system in Canada. Um, but the I recommend co-op for students who are looking at it and going into your career after graduation. Having that co-op experience is a huge big step into that full-time job. And it also gives you a chance to try things out and learn what you don't like as well. And some students say, I've decided to go to grad school because I've seen what an entry-level job looks like, and that's maybe not what I want, but maybe I'll specialize in this particular thing I'm interested in, and then enter the workforce from there. Which is a very individual decision, but co-op gives you that experience to make those choices.
Mhm. And Professor Harris, like you mentioned, actually, the segues really well into another question here about job prospects. So students often wonder, how important is that specific program that I graduate from or the school that I've graduated from? How can I increase my chances of landing a job? So, like you just mentioned, there is sometimes it really varies, right, from person to person. It also depends on what they want to do. Do you have any other insights into how a student can perhaps make a confident decision in choosing, um, their program or choosing which school so that they have the best chances or optimize their chances, I guess?
For which school you choose, um, I'd focus on the educational experience. Um, because all companies know that a university education in Canada in engineering gives you a strong foundation to do what it is. And we have a strong accreditation system in place by Engineers Canada. So I would focus on what's going to give you the student experience that you want. In terms of which type of engineering or which sector, it's I don't have a crystal ball and to say, and you can try and make your own predictions, but we don't really know because things ebb and flow and change. And if you graduate and 4 years down the road, 5 years if you're doing co-op, the economy and the sectors in demand may be very different from what they were what they were now. I did my undergraduate education quite a while ago. And as I was going through, and there were tons of co-op jobs in the manufacturing sector. I worked in that sector. I did a year, a 12-month co-op. I saw a lot of new staff being hired. And by the time I finished my co-op, I've saw, I think, one or two rounds of layoffs as Canada was kind of going into a recession at that time. And then all of my peers who thought we were going to get jobs in the manufacturing sector, those jobs weren't there, and a lot of people were going into oil and gas from there. So it kind of shifted, but an engineering education gives you a really strong foundation on how to solve problems, how to you develop your professional skills. So upon graduation, um, it's a lot of engineering students do pivot and sort of find the career based on their interests in the labor market at that time.
Fantastic.
And can I touch on it really quickly? Yeah, so like Professor Harris was saying, our engineering degrees are all accredited, and so you're getting the same degree as all the other universities. And so what really matters, what I think matters, is the experience you get. And so because Lassonde is a lot of a smaller community, because we're one of the newer engineering schools in Canada, I find that you get so much more opportunity to be involved, to do projects, and you'll get the experience through your co-op, through clubs that you join, projects that you do, and that would make the biggest difference for me.
Wonderful. Thank you so much to both of you, showing both kind of, the industry perspective and the student perspective as well. Um, Speaking about co-op as well as experience, Professor Harris mentioned earlier about hiring students for research. So this student's wondering, can you tell us a bit about this research? How is it done? Maybe they're interested in doing research later on.
So we have a couple programs for in Lausanne where professors hire undergraduate students, often for the summer, to work on research projects with them and work on research projects with some of the grad students. Um, Outside of that program, there's always professors who are hiring part-time part-time researchers as well. A lot of it. Finding those opportunities is about relationship building and seeing which professors are doing things that you're interested in, demonstrating that interest. Sometimes maybe talking to a prof after class or showing up at office hours to talk to a prof. And even if that prof isn't doing the type of research you're interested in, they might be able to refer you to another prof who is. So a lot of it's about relationship building, I think.
Fantastic. And then last few questions here. I know we are getting close to the 1 hour mark. How big are classes in first year? How about the labs? What are class sizes like in the block model versus the traditional model?
Yeah, block model classes will be about 125 students. We'll have two classes of 125 doing the block model this year, and then the other classes are probably around 180 or so if you're at the Kiel campus. You might have one or two classes that could be around 300. Um, but most of them are around 180 students. If you're at Markham campus, the biggest classroom is 135 in that building. So that's the biggest your class could be. And then tutorials and labs. Within each class, you'll be divided into a tutorial section or a lab section. And those are usually around 30 students, maybe up to 36 at the most, based on sort of the size of our labs and the opportunity to ask more questions and get feedback from your teaching assistants. Um, um, so that's kind of what to expect in first year.
And then as they advance into upper years, their classes get even smaller than that, right? As
Yeah,
they enter
yeah,
specializations, right? Yeah.
yeah.
So I guess it really depends on also the specialization that they choose. I believe mechanical engineering is probably our, I guess largest department in engineering right now. So maybe would their classes be a little bit bigger in mechanical than versus like a smaller program like space?
Yeah, mechanical, you might have 100 to 150 in your year, but then sometimes we'll offer multiple versions of the same class, or maybe we offer it once in the fall, once in the winter, so you have a smaller one. And then as you do more specialized electives, you might have classes that are around 30 students in your upper years. Um, Space engineering usually has, I think, up to 50 students in that one. Mechatronics, I think, is maybe around 75 or so. Civil's probably around 140 or so.
All right. And then last but not least, there's a question about first year math. It's so specific, but the student's wondering if they do any 4D vector work in math. Do we know, Catherine, if you recall?
I don't think so. I know we do a good amount of vectors. Mm, I'm not entirely sure.
It's mostly 3D, 2D
Right.
and 3D.
That's what I'm thinking as well. So I don't know if it's a typo or if they're really curious about.
But what you might encounter is looking at a system, a linear system that might be something like four equations, four unknowns, and you'd put that in um, matrix form. If you don't know what that is, yeah, that we'll teach it to you. But you'd look at putting that in matrix form and solving sort of a system that does have four parameters in it.
Right. So thank you both so much, Professor Harris and Catherine. And of course, thank you to everyone at home who's also stayed with us the entire session. We know we are a little over time, but we received such great questions and such fun engagement as well. So it's great to see you all not only curious, but you're clearly invested in your future and you want to know essentially what you're getting yourself into, right? And that's what we're here for. We're here to help you and, really help you every step of the way. Um, from application to admission, and then, of course, into first year and upper year, sometimes it can be a little overwhelming, but it helps when you know you have a community, a group of individuals who are here to support you and guide you through. So speaking of, I just dropped in the chat there some other opportunities for you to stay in touch with us. So if you have any other questions, we didn't get to them today, or they pop up later on when you're thinking back about this webinar, please join us in our Lassonde community Discord server. So I put that link in there. In our server, you can catch up with Catherine and all of our other Lassonde ambassadors to really learn more about not only our programs, but what it's like to be a student here, if you want to envision yourself at our school. And then last but not least, of course, if you want to come see us in person, we do have a spring open house on March 21st. If you're not able to join us in person, we have a number of upcoming spotlight sessions and webinars. So just check out our events page right there in Discovery Days on the Lassonde website. All right. So I do want to wrap up here again. Thank you everyone for your time, for your attention. And if you do have any other questions, I can stay a few more minutes if you need. But otherwise, I do want to wish everyone a good evening. And again, thank you for taking the time of your day to join us.